Hello everyone and welcome to this iXlive webinar. My name's David Cunningham and I'll be your host for this short event. I'm one of the commercial directors of iXblue based here in Paris. So today's event will be about the Delph Subsea Positioning Software and we'll be joined by a colleague of mine shortly remotely. So obviously due to the cancellation postponement of various industry events, we've been unable to meet you in person over the last few weeks. So our aim is to come directly to you with a series of live and interactive webinars to introduce you to some of our new products and innovations over the coming weeks. So the agenda for today will be roughly around about a 10-minute presentation with some introduction of the software from a colleague shortly, followed by question and answers. Now you can log questions on the webinar application. If you look to the right of the screen, you can post your questions. We'll do our very best to answer all of them during the course of the presentation. If you need more in-depth answers, then don't hesitate to come back to us after the event. So what I'll do now is introduce you to Gary Bagot, who's one of our team members in the subsea positioning team. He's actually currently isolated down in Brittany, so unable to be here. But welcome, Gary.
Thank you very much, David. Good morning.
Thank God you could join us. So we're here to talk about the Delph Subsea Positioning Software. So it's dedicated to subsea positioning operations and so on and planning. Gary, maybe you can give us a quick overview of the software.
Sure, David. So I would like to remind our attendees that iXblue subsea product range supports the most demanding subsea activities for the scientific, construction, and naval community for more than 30 years now, with inertial navigation systems, ultra-short and long baseline as key components. So now, Delph Subsea Positioning comes to benefit these activities with two objectives. First, to take further the planning of the operation by predicting the performance of the subsea navigation in a specific mission profile. This is delivered by the LBL planning and the navigation simulation modules. And secondly, a plug-and-play approach to the operational phase with a strong focus on both ease of use and QA/QC, including automated reporting functions.
Okay, so thanks, Gary. So in summary, it's the Delph Subsea Positioning software is a family of applications, 3 modules: the LBL planning, the navigation simulation module, and then the operational module. So what we'll plan to do is to run through each of those modules, and maybe Gary will start with the first module, the LBL planning module. Maybe you give us a quick overview of that.
Yes. So this module is dedicated to LBL array design. You can import your project bathymetry, sound velocity profile, field layout, and then simulate the line of sight in between the transponder for your calibration phase and the insonified area around each transponder for a specific vehicle flying at a defined altitude over the seabed during the operation.
Okay, so we'll actually, a little bit later in the presentation, we'll have a bit more in-depth look at that module. The goal of this exercise is not to go in too much detail in each of these modules, but we'll be available to demonstrate them as we would have done in London at Oceanology. We can do it remotely for you now if anybody cares to organize that with us. So moving to the second module, Gary, the navigation simulation module. Maybe give us a quick insight on what that does.
Yes, so DSP navigation simulation is really innovative. Up to now, David, the estimation of the accuracy for a subsea vehicle or a specific mission was something based on experience. We didn't say on intuition. The only way to confirm that a navigation strategy was a good one, actually it was to go at sea and run some tests and then analyze the navigation data to confirm whether or not the mission objectives have been achieved. So it was a time-consuming and costly process. What our simulator offers is an alternative to real-world deployment to get navigation data. So the workflow is quite simple. So you select the sensors that you want to simulate. So you define your vehicle sensors, your inertial navigation system, a DVL, whether or not you have USBL, LBL. So once you have defined the sensors with their offset and misalignment, so be representative of your vehicle, you define your vehicle trajectory, and our simulator so will generate a data set that you will be able to analyze through our post-processing software, Delph in the same way you would do if you were coming back from sea.
Okay, so in summary then, the tool is in the hands of the user, allows them to explore different approaches to a mission, different configurations of sensors before they put to sea and deploy them. They can model the performance of a certain configuration in the comfort of their own office. Thanks, Gary. So moving on to the operation itself. So the third module, the operational module, Gary, maybe give us a quick overview of that.
Sure. So DSP operation will come as a box, I would say, a 19-inch or 1 watt mount server to be connected to the vessel network. And once connected to the vessel network, DSP operation will automatically detect and preset iXblue vessel and ROV equipment dedicated to positioning and navigation. Okay,
so the operational module deployed on the vessel during the project itself, clearly. Okay, so in terms of the operational procedures, in terms of quality control, QA, QC, is there any features there that you'd like to highlight, Gary?
Well, let's consider the L-bale array installation and calibration requiring hundreds transponder over a large oil and gas field. So our ecosystem will ensure the operator can maintain a clear overview of the equipment setup and the data recorded. So this starts with the simplified pre-live configuration of all the LBL transponders stored on deck by Wi-Fi, the assignment to their respective location, frequencies, and all the baseline and boxing will be then measured for each array. So we have several intuitive dashboards that will provide confidence that the project requirements in terms of accuracy are respected. And finally, all the raw data are secure, smartly stored, and illustrated with automated report to be shared to all the project stakeholders.
Okay, thanks for that, Gary. That's pretty clear. So now moving back to the LBL planning module, which is the one that I think, Gary, you want to give us a quick run through, a quick demonstration of that module, and you're able to do that on the screen here that everybody can hopefully get a good view of.
Sure. So let's have a look to DSP LBL planning module. So you see here the main page. So you see on the left, you have 3 menus. First, you can prepare the type file that would be very useful for the adjustment of your operation. Then you can prepare the sound velocity profile of your project based on any format like CTD or simple SV that you have been logging. And finally, you will go to your visibility chart study, you will log your digital terrain model and select, I would say, the interposition level that you want. Obviously, you load your project geodetic parameters. Here we have the full PSG database, and you can even use some test point, test coordinate to make sure that it's the right one. We see now the DTM is loading into DSP software. We'll continue to set up our project environment by importing the sound velocity profile that we see here as a curve. And to conclude on our project environment, we obviously import the field layout and also the contours that's in a DXF format. And well, so now you get the overview of your project. So we'll also specify something important: the flying altitude of your subsea vehicle. So here I set up a vehicle, an ROV with an L-bale transceiver. Here it's Ramses. So this vehicle would be flying at 2 meters above the seabed during my operation. My list of transponder now is obviously empty, and then we add the first transponder by a simple click right on the screen. So here you see this theoretical maximum range of this transponder. I can switch its coordinate display as a grid system if I want, and edit specific maximum range for this transponder and altitude over the seabed. So then I can activate the automatic update of the in-simplified area. Here we see we define the color scale. So in red, we have the area where I get one range available. As soon as I add other transponder, this is automatically updated. Now in yellow, I can see 2 ranges, for example, and so on. And you can see, David, that as soon as I add a new transponder, the distance to this transponder to the other transponders are visible. A list of baseline on the left appear. On this tab, I can see whether the baseline visibility is working or not, and simply drag and drop the transponder of my choice to make it, for example, closer to the other transponder. The visibility map automatically updates, and here on my screen, I can see with the blue line if I get some visibility in between the transponder. This is also, again, available on the left. I can check individually each baseline, the cross profile, to make sure that the acoustic connection can be functional. Finally, I can select the transponder of my choice. For example, here, all the array. I can set common parameters like altitude or maximum range to these selected transponders, and even shift the array to another location if I want. And finally, I can export very simply this list of transponder to an Excel sheet, for example. So that's basically the main functionalities that we have here in DSP LBL planning today.
Okay, thanks, Gary. That's very clear, and I think no doubt will generate a few questions, which we're going to move on to now. So, as I said, the idea of this exercise is not to go into too much depth with each module, but if you want to see what kind of one-to-one demonstration, then we can certainly arrange that if we make arrangements after the event. So, coming on to the questions. Okay, so basically, so Gary, that was the LBL planning demonstration. So the summary then is we've got these 3 modules, the planning module, the simulation module for testing innovative or novel configurations of sensors, and then the operational module to go to sea with. We've got some questions. So here we go. This is around the simulation module, and the question is, how many vehicles and or beacons can I track simultaneously or monitor or model in the simulation module?
In the simulation today, we are able to add up to more than 250 transponders. Okay, so that gives a lot of possibility in terms of simulation. I would say there is no limitation.
Okay, okay, that's clear. There's another question about simulation and array planning. So this is related to third-party beacons. Can you simulate and can you use the simulation and the array planning modules with something other than an iXblue beacon, a third-party beacon?
So, absolutely, David. So actually, what we do here in DSP LBL planning is to simulate the propagation of medium frequency acoustic wave. So we can actually simulate whether it is the Canal Plus transponder that you have on your left, or any third-party medium frequency LBL transponder. Actually, I'd like to make a point on this transponder, Canal Plus transponder. It's a smart transponder with a lot of telemetry capabilities and data logging, but also something very important for the operation of our customers is we have made a strong focus on its autonomy. So we have in this transponder a smart battery management system that can allow to give a very long endurance to this transponder with a simple alkaline battery. And this is, I think, a key to de-risk the operation, to de-risk the transport and the storage, which was a danger inherent to lithium batteries, I would say, when they are in large quantity. And here with this transponder, this HSE risk is actually totally mitigated by providing only alkaline batteries. And when you operate, that also means that you can maybe avoid to do some transponder management, replace a transponder where the battery would have been drained. So I think this is really a key feature of this transponder and a great innovation from iXblue Subsea team.
Okay, yeah, thanks for that, Gary. Yeah, so just a quick note on the Canopus transponder, and obviously strong modem functionalities, the LBL functionality, but also the power management, giving it extraordinary autonomy, let's say. More questions. This is one about vehicle noise. Can you estimate and compensate and manage vehicle noise within the software?
That's an excellent question. We'll be implementing soon in DSP planning this functionality, so to specify the noise of the vehicle and to actually take it into consideration when you build up your visibility map and so the maximum distance your vehicle can hear and interrogate the transponder. Okay,
so today it's not actually implemented, but it will be coming soon in order to make a reliable assessment of the effect of vehicle noise. Okay, good. So there's another question here about ownership. Oh no, we've got one about a pipe route. So can I import my pipe route into the software?
So I can imagine this is maybe related to the simulation module. So if you want to define your vehicle trajectory along a pipe route today, you will have to build up your trajectory on the simulation module itself. We are preparing a bridge to simply define the trajectory on the layout in DSP LBL planning module that will be able to use them for the simulation. Okay, that's clear.
We've got one about how to own the software. Can I buy each module separately? Do they come as a pack? And is there an annual software license fee?
So the software, they come with 1 year of free upgrade and training and support. You have DSP LBL planning, so we have starting to implement it on our online website, dermo.iXblue.com, where actually you can get your upgrade, the support, even some test software, I would say. I mean, if you want to test it. You have DSP simulation, navigation simulation module, which is an add-on, I would say, to Delph, our post-processing software. So for this one, if our customer are already Delph user, it's just an upgrade of the entangles, and we provide the data generator. And finally, for DSP operation, that again come as a server box, but it's also software that we can install on the laptop to prepare a mission. And again, I invite our attendees to contact us if they want any demonstration or test those products.
Okay, so in summary, there's a few different approaches. The simulation software is a module as part of Delph INS. So any users of that software can add that module, and new versions of that software will include it. The planning module is a sort of standalone software, and the operational module obviously lives on board a vessel and would typically come installed on a rack mount PC. So we've got one here about metrology. For metrology applications, Gary, can DSP be integrated with third-party navigation software for calculations?
Sure. So we've implemented some calculation module about metrology in DSP operation, and we have also anticipated the changes with other platforms. I would just say that it can be several configurations that we consider here. So I invite the person who has this question to directly come to us to tell us its project configuration, and in terms of interfacing the equipment and the software, I would say it's totally limitless. We have a software team which is extremely agile.
Okay, yeah, so the answer is yes, give us a call. Here's another one. Can we see AUV and ROV tracking in real time and also in replay during post-processing?
Absolutely, yeah.
Yeah.
Yeah, absolutely. This was also very important for us to make sure that the situation in terms of navigation quality is a simple view in DSP operation. So the vehicle considered will be visible on DSP main screen with some dashboard and an overview of the LBL environment and the overall navigation quality.
Okay, yeah, good. So whoever's asked that question, please drop us a line, and we can show you we can show you what it looks like. So there's another question here. What's the sample rate of Delph Subsea Positioning?
So for Delph Subsea Positioning, we actually want to be representative of a real navigation. So in terms of data generation of inertial sensors, so the accelerometer and the fiber optical gyroscope, we can go up to 200 Hz. And for the other external sensor, we also have something which is that can be set up by the user, for example, for a DVL or for a USBL at 1 Hz.
Okay, that's clear enough. We've got one more question, Gary, and it's a good one. You'll like this one. Can we organize a real demo in the field?
Absolutely. I mean, we are ready. So I would be pleased to receive any detailed request on that. So contact us.
Yeah. So yes, please. Any more questions? I think that's about it, Gary. So yeah, end of questions. Yeah. Okay. Oh no, hang on. Stand by. There's one more. Here it comes. It's just coming in here, Gary. Okay, so it's about a user creating their own library of sensor specifications. I guess it's for the simulation and maybe the planning. So can I create my own library of sensors, INS, LBL, with specifications set up? I guess to bring and plug into the modeling software.
Yes, so for the simulation, what you do, you select the inertial navigation system of your choice. So this is an iXblue inertial navigation system. And then in terms of external sensor, so the USBL, the LBL, DVL, pressure sensor, and so on, this is totally open. You can set up the equipment of your choice with specified accuracy, specified noise level, and so on. So I would say it's totally open to external sensors.
Okay, yeah. So people could set up a library of typical sensors that they might want to use. We've got one more here now about training. How and where can we get training?
So we are ready to offer training, even if the situation is quite specific now. We can remotely provide by video call some training to our customers, and then as soon as the situation comes to normal, they can join our training school in Aberdeen. We can also do that to any more convenient location for them, like the office, for example.
Mm-hmm. Okay, yeah. So we can train people anywhere. We can train them remotely. We can train them in our offices, particularly Aberdeen. We're set up for that. Or we can come to a vessel or elsewhere. So I think that's it for questions. So we're going to call it to a halt there, Gary. So thank you very much.
Thank you very much, David.
Thanks for joining us.
Actually, I would like to remind our customer really that they are more than welcome to come to us, to contact us, to share with us their project challenges, and they will be probably surprised that we have many innovations to promote, not only in terms of software and hardware, but also in terms of methodology for the deployment of the transponder with low cost, low carbon footprint methodology.
Okay, thank you very much, Gary. Thanks for joining us.
Thank you, David.
Cheers. Okay, well, so thank you very much, everybody, for joining us today. I hope you enjoyed the webinar and you learned something and had your questions answered. If not, then please don't hesitate to contact us after the event. We'll be posting this broadcast on our website after the event. So if you want to relive the experience or indeed direct it to any of your colleagues or associates, then please feel free to do that. We'll be repeating this subject matter on a webinar later today for the other part of the world that weren't able to join us in this one. We'll be running more webinars through the month of April. And in fact, one for your diary could be the 28th of April. We'll be covering the DRIX topic with a couple of webinars along this same sort of format. So I hope you can join us for that. In the meantime, thank you very much for being with us, and we hope to see you again soon. Bye-bye.